Hello and welcome to the final video for this 5-part series where we look at each of the topics covered in this unit. So we're doing exercise 2I, and this is on using simultaneous equations with substitution. This is a small topic that will be expanded later. So I'm going to do a few of the questions from question 1. We won't worry too much about problem solving for this topic just because it is a bit more advanced. And we want to make sure you have a firm grasp of the fundamentals before we try anything too difficult. So don't be intimidated. This is about as hard as it will get, particularly on your exam. Okay, so let's look at 1A. So we're being asked to solve each of the following pairs of simultaneous equations using substitution. So I'll write down my equations. I've got x plus y equals 3, and we have y is equal to 2x. And if you recall, when we use substitution, we can just take something, if we know what y equals, this being the term 2x, we can just take that 2x and we can put it in every time, or we can substitute it in every time we see a y in any other equation. So this is what I'm going to do. I'll take this equation and I will just substitute it in here. You may remember this from class. So we take x plus y, which is 2x, so x plus 2x is equal to 3. I can then simplify by grouping my like terms. X plus 2x is just 3x is equal to 3, and then if we divide both sides by 3, we find out that x equals 1. Let's do another one. So that's x equals 1. So part B, we have x plus y equals 6, and we have x equals 5y. As before, I'm going to take, we know what x is in terms of y, so I'm just going to take this and substitute it into the equation up here. So that will give me x, which is 5y, plus y is equal to 6, and if I add these together, you'll see that we get 6y equals 6, or in other words, if I divide by 6, y equals 1. Again, we're getting these very simple problems. Like I said, it's not going to be anything super duper complicated. We want to keep it basic. So we'll look at part C, and what I might get you to do, so I'll just write this down, x plus 5y equals 8, and we have y equals 3x. I can already see what the answer might be, but I'm going to give you a moment, and if you can, just spend a moment, pause the video, see if you can work it out, see how you do, and we'll come back and have a look. Okay, so that may have been long enough. If not, pause the video. Okay, so we'll go over the solution now. So I see I can substitute y into this equation up here from this 3x, so y is equal to 3x. We'll substitute that. So we have x plus 5y, in this case we know y is 3x, so we have 5 times, I put the y in brackets, 3x, and that is equal to 8. I can then expand my bracketed term, so we have x plus 5 times 3x, which is 15x, is equal to 8. I can then add together my x terms, that will give me 16x is equal to 8, and if I divide both sides by 16, that tells me that x is equal to a half. And that is how you would do part C. Okay, so we're looking at question 5 now, and I've picked one out that has sort of a word problem feel, so we're incorporating a bit of exercise 2E into this problem. Okay, so we're being told that the sum of two numbers is 48, and the larger number is 14 more than the smaller number. And we're being asked to write two equations and then solve them to find the two numbers. Okay, let's try and unpack this problem and do it logically. So first bit of information, we know that the sum of two numbers is 48. I can write that. So let's say, let our numbers be a and b, so we're trying to find a and b. We know the sum is 48, which is to say a plus b equals 48. Okay, so there's one equation. There's equation 1 here. And we also know the larger number is 14 more than the smaller number. In other words, if let's say b is our larger number, so b is 14 more than a, or in other words, b is a plus 14. Okay, we have two equations. We can now solve them simultaneously. I know what b is, so I can substitute it in up here. And what we get is a plus b, which is a plus 14, is equal to 48. I don't need these brackets here, so I can just remove them and add my a terms together. So we have a plus a, which is 2a, plus 14 is equal to 48. I can subtract 14 from both sides, so that gives me 2a is equal to 34. And then finally, when I divide by 2, that tells me that a equals 17. And that is how you would solve question 5.